Now let's see how can we connect a circuit on a breadboard. Let's say we're going to connect this circuit right here. It basically has two voltage sources. A battery is just a voltage source, and we have three resistors. Now, if you are doing this experiment online, then you can simply just use two different power supplies, one set to 3 volts, the other set to 7 volts. If you are doing this experiment in person, then we don't have enough power supplies, so you could just simply use one power supply and set it to 10 volts, which is 3 plus 7 volts. Now, when you are going to make any measurements that involve the point B, you won't have access to point B because uh, we, uh, we only used one voltage source and set it to 10. So you could just simply use the theoretical value for any measurement that has the point B in it. And I will talk about this in a bit. So let's see how we can connect a circuit to the breadboard. So now I'm going to go here. Actually, let me connect the circuit first without a breadboard to see what use the breadboard is, or why do we use a breadboard. So we have three resistors like this, and we're going to connect them. I'm going to connect this one here, and I'm going to connect this one here, and then connect these two, and then I'm going to get a power supply. And don't use the potato or the lemon. I don't know what these two do. So this is the first one, and this is the second one. I'm going to set this one to 7 volts, and I'm going to set this one to 3 volts. Now, you see the negative terminal of the 7 volts is connected to the positive of the 3 volts. So this is the negative of the 7, and it is connected to the positive of the 3. And then the positive of the 7, which is this one, is connected to R1, which is this point right here. And the negative here goes to this point. So it doesn't matter if I connect it here or connect it here. This is basically just the same point. So now we have the circuit ready. Now if we click start simulation, we see that this power source or this voltage source is giving us 7 volts, and we have 3 volts here, and we have 6.67 milliamps flowing through the circuit. Now, instead of having all these wires, we could simply use the breadboard. Now, in here on Tinkercad, it may not be too obvious because we can just use we can simply click, and here we have a wire. But in a lab, connecting wires is not very convenient, and using a breadboard would be more convenient. So I'm going to stop the simulation, and I'm going to delete all these wires right here. And now I'm going to, oh, by the way, I forgot to change the value. So we have 820 ohms. So this is going to be ohms, and this is 820. And you see how the color band has changed accordingly. And here we have 820 as well, and 820. So now I'm gonna connect the resistors on a breadboard. Now, first thing to note is that I'm rotating the resistor by pressing Shift and R. Now, if you connect the resistor like this on a breadboard, this is wrong because you have basically shorted the circuit. Since we said that these, you see the highlight, these represent 1 point. So I basically connected the resistor, the two sides of the resistor together. So I basically did something like this. So we have shorted the resistor now. This resistor is shorted, and current is going to take the path with less resistance, and it's not going to flow through the resistor itself. So this is wrong, a wrong way of connecting the resistor on a breadboard. However, if I rotate it like this is correct. You can just simply put it anywhere you like. Same thing, this is correct because these are not connected to these. So we can put the resistor between them. So now I'm gonna connect the circuit. So I placed this resistor in here. Now I'm gonna this resistor is gonna go right here. I notice how I placed them on the same row because these two legs of each resistor are connected together. And then I'm gonna add this one right here again because this terminal of this resistor is connected to here according to the schematic. And notice that the other side of these two resistors is connected together as well. So you see, we have connected them to the same row. So now we have the resistors connected. We are going to add the power sources. So I'm going to use this as the positive. I'm going to connect it here. And I'm going to connect the negative here. Now, if I click Start Simulation, we have 0 amps flowing through the circuit. What's missing? We did not add this connection right here. So this is the circuit. Yes, it's connected now, but we still need to add a wire from the power line to this row. And we need to connect the ground as well. So now we have the circuit connected. Click on Start Simulation, and we have 8.13 milliamps. And it's different from what we just had when we connected the circuit here because we forgot to adjust the values of the resistors.